B&B Electronics provides the hardware and applications connectivity stack that equips system integrators, OEMs, carriers, and application software providers to deliver on their promises of optimized asset performance. Whether you're working with copper cable, wireless, fiber optics, or cellular data networking, B&B Electronics helps you build intelligent networks.
Welcome to Engineering Live. I'm PD&D and ECN Editor-in-Chief, David Manti. Today we've assembled an expert panel to discuss the Internet of Things, where we are now, where we'll be in 5 years, and the key components and products that are making connected intelligence not only possible, but profitable, particularly in the industrial industry. M2M and wireless have been described as one of the biggest current markets for the Internet of Things. Is this true? And what are the specific component and product categories that are going to be impacted? Larry, would you like to take that first?
Good morning from Sierra Wireless headquarters here in Vancouver, Canada, where it's raining as usual. Sierra, a public company, so you can follow us. We made a significant transaction last year by selling our AirCard division. Some of our viewers may have former AirCard USB modems or hotspots made by Sierra. And we transformed the company into 100% machine-to-machine last year, which shows our conviction and belief in the growth in the market. And we, being public, we announced our results last year. We did just under $450 million in machine-to-machine cellular modems like this that were specifically made for IoT or the machine-to-machine market.
Okay. Richard?
My view is there's a number of reasons why the industrial market can be one of the first to take off in the IoT space. And number one is, whether we like it or not, the M2M and IoT, it's almost kind of a rebranding of somewhat the same thing. And clearly M2M has been in existence for some time. So there's already a history there. People have evaluated it and are starting to use it in anger for a number of applications. And as we've heard, companies like Sierra have been very active in this space. The other thing I think that makes industrial particularly interesting versus maybe some other market segments is just simply that the people involved are looking at very much about what this technology can deliver to their bottom line. It's not for them a fad or a fashion. It's really a case of, let me understand the numbers. What value are you bringing to me? Are you enabling me to monitor the state of my motors? Are you allowing me to understand whether a certain piece of equipment is about to break down? Are you allowing me to maybe do software upgrades to a particular product? And so I think for the industrial segment, it's possible for the companies to get their head around the value proposition fairly readily. And that's one of the reasons why in these more, if you like, kind of adult-to-adult conversations that you see in the industrial space, I think that's why you tend to see the greater level of interest.
Okay. David?
Yeah, it's quite interesting, both points of view that I already heard today, and it's interesting because in the industry it's a market, it's a segment where there is money. I mean that people is already spending a big amount of money, like trying to make the process even better and to integrate new things and to save cost. And for this reason, people in the industry is already used to spend a lot of money on that. So for this reason, it's a market where the new advances will be so significant in the short term that I think this is one of the main reasons that the IoT will be really getting into this industry, because they are already making this process, they already have this chain of value, and they want to improve it, they want to save costs, they want to make it better, they want to interconnect everything. So this is an incredible chance to make things happen at a really low cost and to have at the end a big earns in a segment that is moving most of the money of the whole world, of the whole verticals of the IoT currently.
The new levels of automation and industrial Ethernet have birthed the term smart factories. How are we delivering more precise control to the factories?
Factories are kind of an interesting situation because clearly you've got control systems where real time is critical, and therefore high performance gigabit Ethernet really is rules the roost in terms of trying to get data in and out of equipment. I think we're going to actually see over time wireless technology start to appear in factories. And at the moment it's kind of funny because often when you talk about, use the word wireless in a context of a factory situation, people's first reaction is, man, you got to be kidding me. The latency, I'm worried about the robustness. This can't really be a technology that's appropriate. And I think that what we're going to see is clearly, for obvious reasons, that people tend to be conservative. We're going to see technologies, and are seeing technologies like high-speed Ethernet, and industrial Ethernet roll out into the factory environment. But slowly but surely, I think we will start to see wireless technologies roll out as well, simply because it will allow technologies like the IoT to be actually installed into a manufacturing environment far more easily. And clearly, it will not be used for some of the real-time type applications, but it will be appropriate for other type of generic sensing situations. Maybe it's tracking of products, or the overall environment, or the status of tools or equipment, or how they're being used. So there are many other aspects where potentially it's not real time. So I think, yes, we are going to see these smarter factories as part of the overall flow of IoT into the world that we live in.
Okay. David, could you talk to the point a little bit about some of the smaller sensing applications that will be connected as a part of the Internet of Things?
The thing is that we in Libelium, we have taken part of this kind of horizontal revolution, not only focused on a specific vertical markets like the industrial ones, but trying to get a horizontal platform to make things happen at the same time. So for example, there are a couple of quite interesting markets that are coming up. That one is related to smart quality, to smart water sensors. So they are like water quality sensors, which are quite interesting, and that some years ago wouldn't really get into the market because there was a technology that wasn't prepared to be deployed in the field. So this is quite interesting, the smart water sensor, and at the same time environmental sensors like, for example, CO or CO2, which are allowing people to measure even the fires in forests, which are new things, are incredible new applications that some years ago couldn't even be imagined. So these are just some examples, and overall, these new smart cities technologies like the smart parking that you mentioned before, that knowing which is the flow of traffic, where the cars are placed, which are the free spots in the street. So all of these things are really new for the environment of the smart cities, of the smart citizen. So yeah, definitely these three, for example, smart parking, smart water, about water quality, and environmental sensors are three of the main parts that we see in Libelium that the customers are requiring more and more every day.
Okay. I know one of the biggest concerns is security. So, Larry, if you could possibly chime in, do the technology and interoperability standards exist to not only make it possible but safe, and how much security is enough, particularly in industrial settings?
So, one thing we talk about M2M or IoT here at Sierra, we look at it as 10 very distinct markets. Industrial is one of those 10. Other examples would be Tier 1 automotive, or networking, or healthcare. So what we find in security is it's really an application-specific environment. So if you're running credit card information, or healthcare information, or personal information, the level of security is going to be high. If you're simply counting cars on the road, but you don't know who's in those cars, then like security would be low. So our general answer on security is it needs to match the application, and it needs to be end-to-end. There's a number of subsystems in between, and the whole security picture needs to be thought of from the device side all the way into the back end. And on industrial, I mean, we've literally done thousands of different industrial applications. I'm looking out my window at a Cat diesel generator right now. All these high-value pieces of equipment are covered by cellular now because they can look at maintenance data, they can prevent a truck roll, they can look at the performance of the device. But really, if the information gets out or has a security issue, it's not a big deal. What you don't want to do is having somebody control the machine, of course, which can be done remotely. So really, security is very application specific, and we have a library of different tools we can use. And a lot of them are industry standard, like SSL.
Okay. I mean, You mentioned 1,000 different applications. I'd like to kind of go around. What would, Larry, starting with you, what would you say is one of the more interesting or unique applications that you've seen IoT go into?
So, I mean, you know, in the industrial realm, we do a lot of high-value equipment. And in fact, Nespresso is a big customer of ours, so coffee machines are one example of what we're using IoT for today. And keep in mind that Sierra today is cellular, which by nature, we find the higher value applications because somebody needs to pay for the network operator service, and generally our devices are more expensive because of the robustness of them and the reliability of them. So, I mean, machines are a big one, cars, refrigerated vehicles, anything that has value needs to be tracked or managed remotely. And I mean, the sky's the limit. I think as we are growing as a business, all machine to machine, we truly are just looking at the tip of the iceberg right now. Okay. You know, one of my colleagues here talked about horizontal platforms. One of the challenges in M2M is people have had to build the systems up from the ground up. Mm-hmm. And we need to offer more to the ecosystem to get people and customers onto these applications.
Okay. Richard, how about yourself? What are some of the more interesting applications that have crossed your desk?
Yeah, if I may, I'd like to spend just 10 seconds on security as well, because I think you raised a very interesting topic there, which is undoubtedly, I mean, over time, the data that's transmitted is going to have value, whether it's sensitive data or whether it's just interesting data. That data is valuable, and we need to protect it. And it has several connotations, I think, that you know, really roll into the development. I mean, number one, clearly there's this trade-off between security and ease of use, and I think for our customers it's vital that we not only provide them an environment that is safe so that they can encrypt their data and set up secure channels of communication, but it has to be something that's usable. At the end of the day, all of us could go home and have 12 padlocks on our front door and make it out of 12-inch steel. It just wouldn't really be a life any of us would want to live. So we need to be able to balance that security requirement, but also with ease of use. And another element that's worth considering is that the algorithms that we execute to provide that security are usually pretty intensive. And so they actually have an influence in terms of the overall power of the product. So if you're looking for a battery-powered product, you need to think about how you handle that encryption, and is it done efficiently in hardware, or are you trying to do it in software? And if you do it in software, you're really going to find that you're burning more power. Your radio, if you're using a radio system, is on much longer than it really needs to be. So I think the security question touches on many, many other areas. Moving to your other point, which is kind of what markets do you see, you know, the IoT, and I think it, you know, may come across as a little bit of a trivial comment, but it's almost a question of where don't you see the IoT? And I would challenge almost any application today, whether it's in health, whether it's in fitness, whether it's industrial, whether it's in automotive or in the home, there's a place for IoT in almost all of them. And the only question is how quickly each one of those specific applications roll out. And I can say almost on a day-to-day basis, I see people looking to apply IoT capabilities, everything from a single object in the home, you know, maybe it's a $5, $10 product, all the way through to manufacturing equipment. And the reason you can do that is simply because the cost of adding adding connectivity is just dropped. And we're looking at the point now where many pieces of equipment by definition have some kind of microcontroller inside them anyway, so they are intelligent. All we're arguing about is what kind of connectivity standard we're using. Is it BLE, in which case it may be $1 or $2, or is it Wi-Fi, in which case it may be a few dollars. But you can actually now get to the point where pretty much anything is a target for making it connected and making it part of the IoT. The bigger question is, you know, the why and what's the value proposition that you're going to deliver to your customers.
Okay. Thorsten, if you could elaborate a little bit on the security concerns that some people have, and then as well leading into some of the more interesting applications that you've seen.
Yeah, Thorsten will be joining us momentarily. This is Chris from the IBM Zurich Lab. But the technology that we've developed, obviously IBM is not in the sensor manufacturing business, but we've developed a technology called Mote Runner, which is a sensor software platform. And our strategy is that similar to what the SDK environment has done for the mobile devices, smartphones, we've developed a software platform to enable an ease of use factor for the Internet of Things. So we've made this software app available as an SDK for the last few years, and the idea is that it is freely download available for academia purposes at this point, but the idea is to let the small users begin to develop apps and to get a feel for Internet of Things. That way they can begin to grow and build up this ecosystem so we can start to see some of these robust implementations that we all hope and love will take off over the next couple of years.
Okay. David, your thoughts on security?
There are so many things and concepts to have in mind when talking about security. Is that you can have security in terms of the link layer, for example, when talking about communications, which is clearly that you should just encrypt the information that is flying over the air. Which this is something that nobody is taking into doubt. But then what's happened when the information is taken out from the nodes? Are we talking about a network unique key? Are we talking about a point-to-point key with the cloud? Are we talking about, I mean, this information, this big amount of sensitive information, each time more and more sensitive, is going to bring new challenges from the industry, because it's not only about what's happening is the information is discovered, but what about if it is changes? What about if we lose this information? What about if we send the information twice? So the reliability of the information is who will be behind this, that this information will be accurate, will be, we have even to think about legal issues, about thinking about that, who is going to take care about the reliability of the information. So basically, what I think we have to take into account are a security approach. It's only possible like joining different layers of security. You can think of hardware security in the radio SIEM. You can think about I don't know, other kind of client security, talking from the same node to the cloud. So I think there are like 3-4 different layers of security, and nothing, just we just take care of our own security layer. But however, we have to think about what will be the next step, how I give the information so that the next value in the chain, the next player take it and give and allows me that it will be also secure and keep the data stream to the cloud.
That open standards and platforms make it possible for smaller players to enter the market. And some predict that more than 50% of the innovations will come from some of the smaller players out there. I guess I ask, do you guys agree, and sort of what's your take on it? Richard?
You really kind of touched on 2 points there. One is open standards, and the other one is, you know, is all this innovation going to come from big guys or the small guys? I think in my mind, you know, maybe it's from where I'm sitting, I'm looking at, you know, the connectivity side. How do you actually connect an object to the cloud in a pain-free fashion? And I think that what's interesting is for many of the people that are building products, the IoT is a means to an end. It's not the end in itself. They don't build something that they in their own minds call an IoT product. They build a motor, or they build a toothbrush, or they build a cake mixer or a car. And the IoT is really just the way in which you get that data out of the information, you know, get the data out of the product to the cloud, process it, and deliver it back to the user. And so I think for many of those people, the ability to deliver an IoT experience, which is really easy to use, is what's vital. Because then what happens is you're enabling very small guys that maybe, you know, it's 5 guys, it's 10 guys, maybe it's 1 guy, to go off and build a product and launch it to market without having to worry about, you know, do I know how to build a complex radio system? Do I know how to build my own cloud system? Do I understand all of the transport mechanisms and security mechanisms that are required to make this product successful? That needs to just work. They need to focus on what makes their product truly interesting. And so I think, you know, as a supplier to that market, it's our job to make it easy to take companies that are very small and let them really innovate. And I think that's something that we're very passionate about, whether it's a very large company in the automotive space or whether it's somebody in the maker community. We want to be able to enable them with very much a complete solution.
Okay. Larry, open standards and platforms and small players.
So, good question. At Sierra, we have a broad mix of products. We can sell 50 AirLink devices to a small company, and in fact, I was on a roadshow last year, saw a company that there's 8 people in it, and they had one of the most impressive video surveillance systems I've ever seen. They were doing oil and gas sites that were 100 to 300 miles away, and the value of that was very high. But they were using some of the back-end standards that we provided them. So we have horizontal platforms that allow them to move data. And I think in the cellular industry, actually, we tend to be leaders in standards because the cellular networks by nature have standards in behind them. So the thought process is to layer on standards on the Internet of Things or the machine-to-machine aspects of that as well. But right now, we're still early in the machine-to-machine market, I believe. And as a result of that, we're seeing a lot of fragmentation. I think standards will come over time. But to answer your question, I think right now there's room for very small companies doing very specific IoT applications for their customers. And there's room, I mean, we work with everybody from Cisco down to a company that I don't even know the name of with 5 people in it. And we deal with that through our distribution channels.
Okay. David, I'd like to pose the same question to you.
Yeah, one of the interesting things that we do is that we have like 2 different lines. One is the professional line, the one I mentioned, like the project with the smart water quality sensors, the environmental or smart cities like smart parking applications. And on the other side, we have a small brand which gives sensors and devices for the IoT just for makers. I mean, like all these platforms like Arduino and Raspberry Pi, it's incredible because there are like 4 million users already. So there are 4 million future engineers currently using these prototyping sensor boards. Mm-hmm. And I mean, the implications that this will have in the coming up years about what new applications, what new market trends or whatever, how the money will be moving, it will depend on these future engineers, because for the first time in this story, I think there are more people working with sensors at their home than even outside their home, like making in the industry. So I don't know will we be happening in the 2-3 years, but surely will be something amazing, because we have already numbers that more than 5 million young and future engineers are already playing in their garage, in their table with these future sensors and Internet of Things tools. So for this reason, when we started Libellion, we decided to make a new brand, which is called Cooking Hacks. And this Cooking Hacks is like giving the tools for the new makers to cook the future in the IoT. So it's just a way of helping community with new development tools to have something common to make new products and to make new applications in the future. So we believe in that 100%.
Thank you, David. I appreciate your passion. Chris, would you like to add the IBM perspective?
Yeah, well, so Libellum is a perfect example. So we partnered with Libellum a few months ago to develop a starter kit for the Internet of Things, where the small user can go out and go to the Libellum website and buy the sensor packages with everything that you would need to get up and running for your Internet of Things environment, and it's pre-installed with the IBM Mote Runner technology. So you have a combination of ease of use from both the hardware platform and the software platform to enable some of these small users to get out there and experiment, to build these proof of concepts, to work with academia, and then hopefully roll these out into smarter cities types projects that we've been talking about.
Okay, and we're running out of time, so I just wanted to ask or note that 50 billion devices have been estimated to be connected by the internet by 2020. Will there is this the state in the next 5 years? Yes or no, Chris?
Absolutely. I think nobody's a stranger to the terms big data and big data analytics, and this is all being generated from all these devices that are going out there. I think here at the Zurich lab we're working on a lot of nanotechnology, and as devices and sensors get smaller, they're going to be more rampant on everything. We have examples of farms that we're working with where they're tagging the livestock. We have pharmaceutical companies that are tagging individual bottles of pills. I think you're going to see more and more devices out there simply because the cost has gotten down, the battery power is out there, and now we have these wireless environments that can absorb all this.
Okay. David, is everything connected in 5 years?
Yeah, I think, I hope so, and I believe so, but definitely there is a lot of work to do before. One of the key things is like trying to talk everything in the same language. I mean, I know can be public standards, I know can be proprietary technologies, but in the end has to be something that allows us to talk the same language. So I know that it's not going to be easy, but one idea we have to have in mind is that which will be the protocol, for example, the wireless protocol that will be in most of the applications. I think there will be no one protocol. If we learn something from the industry during the past years, is that there is more than one dozen of main industrial protocols in wiring. So imagine wireless that you don't need any kind of infrastructure. So we will be living with 5, 6, 7 maybe different wireless protocols surviving at the same time. And the same will be the cloud platforms and the hardware models and the sensor integration. So I know that this will be a heterogeneous world, and we have just to open the mind right now to accept it and not trying to give our technology as the default standard. So if we keep this in mind, in 5 years will be everything more than connected. Yeah, I'm sure.
Okay. Larry, 5 years.
50 billion was offered up by our friends at Ericsson. So I've seen that number many times. It's certainly aspirational for us all. Mm-hmm. There's no question we're going to see significant growth, debating whether, we've seen numbers anywhere from 12 billion to 50 billion. The fact is, it's a massive number, and we've just started to grow against that. I think the challenges that we all have to watch for as an industry is the fragmentation going towards that. The biggest part of fragmentation goes back to these segments that I talked about. Mm-hmm. An IoT solution for a car, an automotive, is totally different from an IoT solution for an energy company. So we have to make sure, and in listening to my colleagues here, I can tell everybody's actually been active in the field, because we don't talk about M2M or IoT. We talk about these segments and these customers. And a couple of things we have to watch. We need to knock down the fragmentation in the technology, and we need to make it relevant to them. And one of the things we need to really watch out for, we talked about security, but we need to tie into their back-end systems that are available today. We need to recognize they have significant investments in their business information systems. The machine-to-machine devices should tie into that. So I think there's still some work to be done. I'm very confident that the number is going to be big. Mm-hmm. We'll find out in 5 years whether it be 50 billion or not, or whether we can even count.
Okay. And Richard, I'd like to end on your take.
Yeah, just a couple of points. I think number one, I fully agree with the comment made that there won't be any kind of killer single radio technology that wins all. I mean, TI supports north of a dozen different radios, and it really is choosing the right tool for the job, whether Wi-Fi is the right one, or 6-low-pan, or sub-1 gigahertz, or Zigbee. I mean, the list goes on, and people need to understand that at the moment, BLE might be the perfect choice for your application. It won't be for everyone, and so you need to look at what makes the most sense. As for the volume, will 50 billion be the right number? I have no idea. I do know that as of today, we're shipping north of 100 million units a year, and I think you could argue many of those radios go into something you could pretty easily tag as IoT. So the volumes are certainly very significant, and we're seeing strong growth. So I think connecting the world, and if we want to call the connected world IoT, then yes, I think we're going to see big numbers, and we're seeing rapid growth.
Okay. The connected world, I like that. I'd like to thank